Good morning and thank you for joining Modena's webinar on Structure Golden Triangle. My name is Salome. I'm one of the sales account managers. And presenting today will be Tabelo, our applications engineer. Please add all your questions in the Q&A box. Tabelo will answer all your questions at the end of the presentation. We also have a YouTube link where you can revisit all of our previous webinars. This will also be added to the comment box. A link will also be sent to you after this webinar by email for just re-look at this webinar that was presented today. So I'm going to hand this over to Tabelo and enjoy.
Okay. Hi, good morning, everyone. Thank you all for joining this webinar, right? And this webinar basically we'll be going through what we call the golden structural triangle, right? And that's involving Revit structures, robot structural analysis, and then advanced steel. I will be touching a little bit as well onto Dynamo and seeing how Dynamo plays in the whole golden structural triangle, right? Before we get started, I just want to run a poll quickly to just see what software you guys are currently using, right? So if you look on your screen, just select the software that you're using, and I'll just give you guys a few seconds to answer this question. Okay. Right. Okay, so we could just share. Awesome, guys. As I can see on the screen here, we have mainly 50% of the people attending this webinar are Revit users. 2 out of the 20 are robot structural analysis users. 30% advanced steel. 20% of you guys are using all of the above, and 25% none of the softwares here. Right. I'm hoping this will be very useful for you, right? And the approach I'm using for this session, right? I will be starting off by showing you the new features that are very helpful for our discipline in the 3 softwares that I've mentioned, right? I'm looking at the new features for Revit Structure, highlighting unique features that will assist in this workflow that I will be presenting to you guys. New features for Robot Structural Analysis Professional, and then also new features for Advanced Steel 2021, right? I always highlight this because I feel like it's key to know what Autodesk is doing in improving our workflow, and they actually listening to the queries that we put in for them. Thereafter, after I've gone into the new features, introducing the different softwares, I will then focus on the actual workflow that we recommend for Revit Structure, Robot Structure, and Advanced Steel, and actually slot it in the different stages of our projects that we run, right? You will notice, I must highlight as well, this workflow, I've focused a lot on the steel side of our structural work, right? Not disregarding rebar and also concrete work, right? Just take note, you can still do rebar analysis and concrete analysis on robot as well, right? Now, the first thing I'm going to look at, just take note as well, I will have a time for question and answers at the end of the webinar, right? You can just type in your question, and at the end of the webinar, we will address all the questions for you, okay? Awesome. Cool. Right, so the first software I'm going to look at is Revit Structure 2021, right? And if you look at the new features, right, that they've introduced, there's quite a lot of work. If you look at this update to 2021, that's focused on structure, right? And as you'll notice, I don't know how many of you guys are using 2021 yet, but what Autodesk have done, they've integrated your steel connection automation nodes in Dynamo for Revit, right? And they've also integrated structural analysis results exploration in Revit. So it's not an additional plug-in that you need to install with the installation, after the installation, right? And then there's some improvements on creating stiffness and still elements. I will not spend too much time on it, but I will highlight the areas that have been improved. So the first thing I'll look at is your integrated structural analysis results, right? So basically what that means is just this structural analysis panel we would have to install it at a later stage. So with the 2021 installation, the tools come in with the software, right? And the structural results manager and your results exploration tools are basically integrated into Revit 2021. These tools enable structural engineers to explore and document analysis results to gain insight into structural behavior, right? And this allows you to make appropriate design decisions and document those decisions properly as well, right? What are you seeing on the screen? This is basically the results taken from robot, and we're able obviously to visualize it directly in Revit, okay? Now, also depending on the type of analysis performed, results are presented graphically as maps and diagrams on elements of the analytical model used for analysis. Now, basically this integration of the structural analysis results in 2021 enhances the connection between your design and analysis for us as structural engineers, right? Another thing that a lot of guys are starting to use now is Dynamo in the industry. What Autodesk have done now, they've made nodes, some nodes available in Dynamo for Revit specific to structural design or structural engineering, right? There are thumbnail pictures for all nodes. Basically, what that basically means is a little icon so you would have an idea of what that node does. And we also have sample scripts available as well, right? So basically, Dynamo is built into Revit. If you go to your Manage tab and click on Dynamo Player, there are Dynamo scripts that are available. And also as well, you'll notice there are still connection nodes available there as well, right? This means that the functionality previously provided by Autodesk Still Connections, including nodes and sample scripts, will now be available in Dynamo for Revit without any additional setup, right? And these nodes give you functionality to drive still connections by structural analysis results and tightening the integration between your analysis and detailing phases and helping you make better decisions with your connection design as well. Okay. Right. A very nice improvement as well with Revit structure is the ability to edit boundaries and edit patterns and for your steel members, right? You can edit steel objects like steel plates, create contour cuts on beams or plates, bolts, anchors, sheared stud patterns, right? And just show you this. Okay, so Revit 2021 still detailing capabilities have been extended to allow more flexibility when modifying steel elements or connections. Right? To change the shape of a plate, you can simply select it, press the edit boundary button, and stretch one of the plate's edges to the desired location. And as you can see on the screen, and obviously update your bolts as well. To edit simple and complex cuts, you easily select the desired cut using the tab key, press the edit boundary tool as you saw on the screen, and then you can adjust the boundary of your cut, right? And that updates your steel member as well. Right. The size of your holes and circular openings can also now be adjusted in a similar fashion. Right. Select the opening, press the edit boundary button, and then adjust your radius in this case, and that would update your holes or openings. What I've done with this as well, you can also add in global parameters for that. So if you've got multiple holes in your project, instead of editing each one of them alone, you can add like a parameter to that. Revit structure also allows us now to create stiffness on beams and columns, right? Stiffness is an important component of structural steel design, right? They're used to strengthen a steel beam or a column, as you guys know, and a dedicated tool for creating stiffness is now available in your structural connection settings dialog box. Once loaded into your project, it is available from the type selector, right? You can then insert stiffness on the selected steel members by specifying your insertion point. Right. Now, like all Revit families, stiffness have types. This means you can create a library of stiffness inside of your Revit project as well. Right. So you'll notice in there, for example, if I change the size of that column, the stiffness would update as well. Right. The stiffness can get copied, they can get rotated. You can edit the type properties as you would any other Revit family as well. So in this case, you're just changing this to a half size, going into its modified parameters, adding a chamfer to it, giving it a different width, and that gets updated and then added onto your project. The nice thing with this, you can then use those stiffness on other projects as well. Right. This is a very useful tool for just those custom plates and connections that you're modeling. Right. We're able to now insert steel elements or edit steel elements in section views and elevation views. So previously we're limited to inserting steel components in 3D views and 2D horizontal views such as levels and floor plans. Now in Revit 2021, this limitation has been removed, and Revit users may now place steel components in 2D vertical views. And you may also insert a steel plate in an elevation view or a vertical section view as well. Right. This new feature basically gives you the freedom to model steel components in any view and wherever you prefer to see, or create and adjust those steel components. Right. And just lastly, very basically able to now dimension, snap, right, on your plates as well, right? So in addition to creating edge distances for a steel plate, it is now possible to snap its midpoint and create dimensions indicating the distance from the plate edge to its center, both vertically and horizontally, right? I'd like to add on as well with this feature, this is also updated in your advanced steel as well. Right. Now for stiffness and connection plates along a beam, improvements have been made that enable you to dimension them from center to center with a dimension to the center line of the beam web. Because these dimensions are parametric, if you move the stiffness, the values of your dimensions between them will update automatically as well. Okay, right, so for most of us, if we've been using Revit 2021, you'd notice that these features do help our workflow, specifically in our modeling stage, right? I just want to go into our robot structural analysis tools. And as we saw in the poll, not a lot of guys in South Africa are using robot structure, right? And the reason for this is previously we had to sort of create our South African standards to make robots compatible for our designs and analysis in our region. Now what Autodesk have done, they've now added new regional settings, right? I'll take you through the improvements that they've done on your structural analysis for wind load simulations, sequential self-weight load, right? And then also very useful, I find this very useful for projects that I've been working on recently, the core walls results improvement, right? Now I'll be happy to share this with you that new regional settings for New Zealand, right? And South Africa have been added, right? And this is very useful, so we don't have to configure or customize robot after installation, okay? Another change that they've done, I know not a lot of guys use 4K monitors, but what we'd find with robot dialog boxes, they wouldn't show properly on more modern screens, especially when you're sharing screens and stuff, right? So what Autodesk have done, they've now improved this, and these dialog boxes show properly on 4K monitors. Has improved text and graphic sizes and overall clarity of our layout, right? When it comes to our structural analysis, first one I'd like to look at is our wind load simulation, right? So there's a detailed pressure for panels from wind load simulations, accurate results for panels, right? And useful for wind loads generated on complex objects, right? I'll just quickly show you what that looks like. What robot structural professional 2021 offers enhancements with load simulations, as you can see on your screen, right? The wind load simulations feature enables you to simulate airflow around your structure and to generate wind loads automatically. This feature is especially useful with structures that are geometrically complex and for which it is usually difficult to define accurate wind loads. And the wind load simulation features acts as a virtual wind tunnel, displaying color pressure maps on the model in order to facilitate visualization and understanding of wind effects. And in 2021, you can now specify whether to apply pressure as an average load per panel or as a detailed pressure along a finite element mesh. If you opt not to apply the average load, you will obtain a detailed picture on how the pressure will be distributed. This is particularly useful for wind loads generated on complex objects. With more detailed pressure results, structural engineers can better predict and design for wind load effects, thus avoiding potentially costly design changes. Okay. The next one I'd like to look at is your sequential self-weight load for your levels or for your stories on your project, right? And in previous versions of Robot, all load cases, including self-weight, dead, and live loads, were applied to the complete structural analysis model in a single step. In order to simulate construction stages properly, sequential loading for stories have been introduced in Robot Structural Analysis Professional 2021. Sequential self-weight now builds construction stages for each story and collects those results into a single load case. In successive iterations, the deformations for a given story are calculated without considering the stiffness of the stories above. This new functionality enables simulation of the construction process without the need to create phases, which can be tedious and also time consuming. Right. And the next one I just want to look at is your core walls results improvement, right? So robot structural analysis allows us now to define the primary local x-axis direction for a core wall, visualize local coordinate axis, and also explore results in local axis and for individual isolated core walls. Right, and just to show you what that looks like, shear walls are used to resist, obviously, the horizontal loads produced by wind or seismic action in tall buildings, as we all know. And alternatively, a lift shaft or service duct is used as the main horizontal load carrying member. This is known as a core wall, in some cases shear wall. In Robot, you can define a core wall by grouping walls. A shear wall or core wall may be analyzed as a very large vertical cantilevered beam. With the 2021 release, you can also define the primary local x-axis direction for a core wall. And the vector definition is a projection to the XY plane. You can then visualize local coordinate axis for the defined core walls. And once the structural analysis has been performed, additional results can be obtained for the core walls as reduced forces and moments along the vertical axis of the gravity center of the core wall section. And the results of the reduced forces for the core walls are available in forms of diagrams and tables. And remember, with this, you can also send this back out to Revit as well, right? What we've done there, we basically looked at the results in its local axis. I hope you find those improvements useful or enhancements useful to your workflow. Very important, I'd like to highlight once again that our South African regions are added with our installation now, right? This has been the main issue with robot structure. Just so you know, from 2021, South African settings are now part of your installation. Okay, just want to go into advanced steel features. And then after this, I will then go into our golden triangle workflow and then just show you a workflow, how we use the different softwares together to achieve our goals or our BIM goals in our project, right? Now, just before we get into that, I'm just going to look at Advanced Steel 2021 features, right? There's quite a lot of work that's been done on Advanced Steel. I'm just going to highlight a few of them once again, and I'll just go through all the features, right? A very nice one is we're able to now stretch a beam along its system line, right? And there's now a dynamo extension for Advanced Steel 2021 that I'll show you. And then obviously there's been improvement between the interoperability between Advanced Steel and Revit 2021, right? The first one I'm going to look at is the ability to stretch a beam along its system line, right? And it sounds simple, but if you've worked on Advanced Steel, the ability to stretch a beam would be quite frustrating, right? And I'll show you what Autodesk has done in a moment. Right, so now when modeling straight or curved beams in Advanced Steel, there may be situations where it's useful to extend or shorten a beam along its system line without accidentally snapping to an undesired location. I used to do that a lot. Now, a new lengthen option in Advanced Steel appears when you position your cursor next to the beam endpoint. After selecting this option, you can then stretch the beam along its system line. And the same behavior applies to curved beams. You can hover over the endpoint of a curved beam, select lengthen, and stretch it along its arc. This feature offers users better control when modifying the length of straight and curved beams in Advanced Steel. Right. The next one I'll look at is our new messaging framework for user sections, right? So if you've created custom sections in Advanced Steel, like what you're seeing on the screen there, Advanced Steel wouldn't really tell us why it couldn't create certain custom sections. What they've done now is just basically improved our the way Advanced Steel communicates with the user as well, right? So you're able to see exactly what the issue is in your custom sections that you'd be creating. Right, and I'll just show you guys quickly how that looks. Advanced Steel introduces a new messaging framework when creating user sections. And once you've defined 2D shapes of your user sections, you can add them to the Advanced Steel database by pressing the Generate All Sections button on the ribbon. A user section generation palette will appear, and this dialog provides details on which sections have successfully been created, which ones have not been created, and why they're not successful as well. This information makes it easy to correct common issues. For example, you might need to assign the correct layer to the outside contour. In this case, you need to close a polyline. The contour is not properly closed. Or even assign section names if you forgot to do so. Now, once you've made the necessary corrections, you press Generate All Sections button again, and all user sections will be generated successfully with the correct information than there. These sections will not be available in your dialog box and can be used in any of your upcoming projects. Now, this feature has simply. I hope that excuse me, guys. My internet just dropped a bit. Just want to take us everyone with us. Awesome. Right. The next feature I want to look at, just to note once again, like this feature is very useful. I've worked on a project before where I had to create custom user sections, and it would be very difficult to know what has happened and why I can't create a specific user section. Another enhancement that's been added to Advanced Steel 2021, it's the ability to switch connection pattern objects, right? Now what this basically means is, for example, when modeling steel components, I just want to show you here. When modeling steel components, it may be useful in some situations to replace holes with connectors or vice versa, right? In Advanced Steel, selecting anchors will give you access to the new change into holes option and the contextual menu, right? And this feature enables you to replace the connectors with holes, as you can see on the screen. And the same behavior also applies to bolts. You can replace them with holes using the same option. If you wish to replace holes previously placed in steel components with bolts or anchors, this also is now possible via the contextual menu, right? You may also add parts to bolted connections with the feature add objects to connection, right? And in this case, this feature greatly improves flexibility when modeling holes and bolts. So previously, if you had created a connection and you hadn't shown the anchors, you'd have to go into the actual connection and add in those bolts or those anchors. In this case here, you just have to right click, go into your contextual menu, and then add your previous bolts and holes. Okay, the next feature I'm going to look at is the ability, we're now able to create monowheels panelized handrail systems, right? Along selected bins between 2 points. And I'll just show you what that looks like so we can get into our workflows, okay? Right, so with Advanced Steel, you have access to a new dedicated monowheels panelized macro, right? With this, in the extended modeling tab of the ribbon, you go and select your beams, select 2 points, and the dialog box pops up, right? Simply select the supporting beams, click a start point, end point, right? You go into the dialog box, and then you're able to edit it accordingly to what you want to design. Within the properties dialog box, many parameters may be adjusted, as you can see on the screen. For example, max panel length, handrail type, post type, various offsets, and obviously so much more. Each panel segment may be controlled individually, offering you the flexibility to create various monowheels configurations to meet your needs. And you may choose among several options for the ends of the handrail and the kick plates for each segment. And this new dedicated macro enables users to create monowheels panelized handrails and stanchion systems easily and efficiently in Advanced Steel 2021. I hope you guys would find it useful. Right. Okay. Another feature, just have 2 more features and then we're getting into the workflow, right? With Advanced Steel, we're now able to ignore holes on objects for numbering, right? And just very quickly to take you through this, right? When working with steel components in Advanced Steel, you may wish to utilize holes on in those parts to drive part numbering, right? For example, you may have a set of parts that are similar in size and shape, but have different number of holes. In Advanced till 2021, you can select use holes for numbering in the object properties dialog to utilize those holes for part numbering. To execute the numbering process, you simply press the numbering icon, select the members that you want to number, right? We see that the 3 central beams receive, you'll notice the 3 central beam, they receive the same number, the outside one has a different number, etc., right? And this feature gives users more control of the part numbering behavior. And lastly, when you're now able to show high detailed parts and assemblies in the 3D model, right? Just very quickly, I want to go over this, right? With Advanced Till, you now can create shop drawings for an entire model or selected parts. As such, it may be useful to highlight in 3D views those parts which we couldn't do previously, or assemblies, and that have already been detailed, and those that have not. Right. Now with Advanced Till 2021, using the search tool, you can easily find parts that haven't, for which the single part shop drawings have already been created, and what basically Advanced Till highlights those parts, right? You can then save the search request, making it available in the Project Explorer for future use. Right. Just very quickly, there's improvement on our interoperability between Revit 2021 and Advanced Till. Basically, there's shared level of detailed 350 model information between Revit and Advanced Till. We're able now to transfer still members and connections, import or export synchronized changes between 2020 Revit 2021 and also Advanced Till 2021. Right. Other improvements, there's support now for our SQL Server, right, by Advanced Till, and support for SQL 2014 Update 3 file format to eliminate security vulnerabilities, right? And we can share this information later as well, right? I just want to get into our golden triangle workflow, and what I've seen in the industry, right, the business challenges that the structural guys have been seeing is an increase in project complexity. There's design is disconnected from detailing, right? And hiring and retaining skilled workforce is quite a challenge as well. And then also material waste and delays on the job site. Now, with this workflow, we intend to improve or connect design and construction, focusing on different stages of a project workflow, right? And our portfolio of BIM technology supports end-to-end workflows across the building disciplines, from the project conception to completion. Now, with the tools I'm going to show you, you can begin your BIM workflows even at conceptual stage, what I've called model on there, right? And all the way through to fabrication and installation on site. Right, and the way I'm going to go through this workflow, we've basically grouped it from, we're going to start off by conceptual stage, which is a modeling stage. And I'll show you tools that you could use from the golden triangle to create multi-material structural models, automate some tasks and design workflows, right, using Dynamo, explore parametric conceptual designs using Dynamo as well, and also collaborate with other design stakeholders on Revit, and then also keep all designs within the same design environment, right? What I've seen in the industry, some guys would analyze on a different software, right? Then print out that report, model it in Revit, right? And the problem with that is your analysis and your design changes are not linked and placed in one software. So just to automate tasks and design workflows, what Autodesk uses would be your Dynamo, right? And Dynamo is installed with Revit. You also have what we call Dynamo Studio, which is a standalone version of Dynamo. Okay. You can use, excuse me, let me just get started. You can use Dynamo within the Revit environment, right? And as you can see on the screen there, we just opened up Dynamo, right? And in there, we're able to go and select the architectural features from the architectural model, which goes into our Dynamo script, right, or into our Dynamo. And in there, Dynamo allows us to select edges of a slab, for example. And in this case here, we can mess around with the number of beams just using a slider node, right? And just quickly create a concept. What Dynamo allows us to do as well as using computational design is create complex steel designs, as you see on the screen there, right? Using computational design capabilities, right? And with this, we're able to quickly go through different design options. For example, if we now wanted to change the amount of arcs, number of arcs, adjust the height, right? And traditionally, if we had to draft this, this would take us quite a while to get to these results. This can then get created as a structural model in Revit. And what Dynamo does, it just uses the steel members that you have defined, using that computational design to generate the structural model itself, right? And just take note, this once again is still at conceptual stage. Once this is done, we then take this into, you can go, once again, go into Revit and further develop your design or your model, right? And the nice thing with this, the way we would work with this would link an architectural model into our Revit structure and then start coordinating our design with the architectural file as well, right? Now, what Revit allows us to do, allows us to design with intelligent parametric objects, connect your structural design to the detail model as well. And then you're also able to extend models for analysis, visualization, coordination, and collaboration at later stage. Revit is for design, specifically in this case for steel connections. Design for steel connections, design and review can be more streamlined by working in a BIM environment with 130 steel connections matching up between Revit and advanced steel. It's very important to note that the connections that you'll be using in Revit would be the same connections that you'd find in advanced steel, right? So if you create a connection in here and modify it in Revit, you can still, you'd be able to export it out into advanced steel, as I'll show you later. Do your fabrication and create your shop drawings from there, right? And the nice thing as well, you can also update the connections from advanced steel and send them back to your Revit software. In this case here, we're just modifying ourselves. I just want you guys to take note on how, right? And the nice thing with this, if I had a similar connection in the rest of the model, we would be able to just copy the connection and apply it to the rest of the model, right? Now, once our model is generated, or once we've grabbed our conceptual model from the architect, we have seamless connection between design and analysis using Robot. We're able to now conduct advanced analysis, easily visualize detailed analysis results, pull quantities and value engineer from the design model, and obviously optimize structure running code checking, and also guarantee safety and human comfort, right? And we do this with a link between Robot Structure and Revit, right? Revit has the ability to analyze internally as well within Revit, but for more detailed analysis, we'd use Robot Structural Analysis Professional, right? Okay, so your Robot Structural Analysis Professional software, in this case here, we basically create the model in Revit. You'll notice that in Revit, your structural components have analytical properties to them, right? Where we're able to then go in and add loads. In this case here, you can go in and specify area loads for specific slabs. We can also create load cases inside of Revit, right? So in Revit, in this case here, we've just created a live load for that specific slab, right? This analytical model then gets sent to Robot Structure from Revit, right? And what this does, it creates a bi-directional link between the robot analysis model and your Revit file. Right. So what I'm doing here, I'm just basically sending out the model to Robot Structure. That model comes in with all the steel components, the walls, and the loads that you would have created in Revit. Right. Robot allows you to then change different view interfaces. You can check the load cases that were generated in Revit, right? And the nice thing with Robot, if you needed to add in additional load case combinations, you can also automate them inside of Robot and then run your calculations on Robot structural analysis, right? So what I've done in this case here, I've just created the calculation. And what I'm going to do now in this case is just apply the diagrams and the maps on the model itself inside of Robot structural analysis, right? So in this case here, these are maps. We're able to normalize it inside of Robot. I can adjust my parameters and apply them to the entire model as well, right? These results, right, can also be exported out as tables, right? So it's not just pretty images that you're looking at, right? And these are the results shown in a table form, okay? We can also, like I said, mentioned earlier, you can go to our maps, apply different displacement maps, as you can see on the screen, rotate the model around its Z-axis, as you can see on the screen there, right? And you can also run orbits as well, pan, etc., right? We can also add in an FFE mesh, also add in descriptions to the mesh as well, and also characteristic points on the robot analytical model. Right. What we're doing there, we're hovering on the different beams, and we're able to actually see the results for specific components in our structural model, right? The map I'll show you now is a deformation map, and we're able to also animate and show the deformation of our structural analysis as well. This can be saved and exported out as a video file as well, right? I've seen working with architects in some cases, they wouldn't understand when we communicate deformation to them as well, right? In this case here, we're looking at calculations for specific members on the model. We get our results, right? And able to concentrate on specific results on specific members of our structural file or structural model. These results can also get grouped, right? You can create a group. In this case, the beams on a roof. Save those groups, optimize their weight as well, run a calculation, and then what Robot Structure very quickly with those beams gives us results and detailed results for those beams on that Robot Structure model. If you needed to change all of them, you can apply a change on all those members. And the nice thing, just take note as well, as we're making changes in Robot, those changes will go through onto the Revit file. And in this case here, we're just updating the Revit file. In this case, we're sending out the results, and the components are also updated within your Revit file. Right, the nice thing with Revit, the same maps that we're viewing inside of Robot, right? We can now apply them in Revit, right? And as you can see, it's just a matter of selecting the results that you'd want to look at and applying the view back in Revit, right? So the link between Revit and Robot Structural Analysis supports an iterative design process and exchange of data between designers and engineers, enhancing collaboration between them and further demonstrating the value of BIM to structural engineers, right? I'm just gonna skip this. Dynamo as well can be used for verifying or creating these models, right? And just very quickly, I don't want to spend too much time of it on this, but we are able to create those analytical models using Dynamo, right? Or that model will be taken from Revit and using Dynamo go through different design changes and design options as well, right? As you can see on the screen there. Right, so you can just adjust number of frames, etc. And then obviously that then goes into your robot model, right? Now, okay, so once the analysis has been conducted, the engineer can easily explore all results and start the design of structural elements, right? And they do this using robot structural analysis professional. So in this case here, the engineer wouldn't want to go in and draft, right? The problem that I've seen now in most of the clients that I've been working with, we have clients as well that have engineers actually creating the 3D model, right? Without having to hire an additional resource. And the reason for this ability that robot has to quickly generate the steel members, right? And update the Revit model itself. In this case here, we're updating those beams to an IPE steel section, right? It's just basically selecting, in this case, just selecting the beams that we needed to update. As I showed you previously, we would group it so that when we apply a change, it changes the entire group instead of working on individual components. So those IPEs are now updated in Robot. With our results, we can check our codes as well from Robot as engineers, and then obviously update the Revit model as I showed you previously. Right. Revit provides access to a variety of parametric steel connections, right? Enable connections to be modeled with higher level of detail, right? And this includes a built-in steel connection design engine based on US and European codes, which allows structural engineers to verify the connections in Revit before the model is sent to the steel detailer for final detailing, right? You'll see in this case, inside of Revit, in this example, they're using an AISC code checking method. We could also use Eurocode to check our connections inside of Revit, right? This report is taken from the code check done in Revit, and it will tell you if there's a fail on our connections, and it tells exactly where the fail is as well, right? And this is specific to steel connections. Okay, right. After we've done this, we then need to document and detail the work that we've done in modeling and obviously from the analysis process, right? And now to do this, the solutions would do for specifically steel would use advanced steel, right? To create a connection between the Revit model and the detail model, right? Advanced steel is basically built on AutoCAD. It's a powerful modeling engine that connects with Revit and is also integrated with Dynamo, right? It accelerates design and steel detailing, automates shop drawing production, right? And I just want to I'll take you through the different workflows for Revit and advanced steel. I do just remember, guys, you can ask questions, right? There are some questions that I'm seeing that have been asked, and I'll address them in a few moments. Okay. All right. So, nice thing with advanced steel, right? Once again, you will notice, we just go back quickly, right? There is a link between advanced steel to Revit. From Revit, you just export your model as an SMLX file. It imports, you'd open up advanced steel and import that model into advanced steel. Right now, that same connection that we're working on, we'll notice in here that there's some changes that need to get done to that connection. Now, the nice thing, once again, because the two solutions are bi-directional, you can do that. What we've done here, we just quickly pulled out a list of parts for that specific connection, right? And I'm also going to create additional plates. You'll see in this case here, we're just going to create an NC file for all the plates that we have in Advanced Still, and this NC file is then quickly sent out to our fabrication machines in our factory, right? And this is actually how quick it is to generate those NC those NC files. And also in this case here, we're just creating shop drawings in Advanced Still from that same model that was generated from Revit, right? In this case, you notice we're adjusting the size of our plate by changing the bolts. You notice that Advanced Still picks up that there's a revision required. You can specify who the person who did the revision, update the model, and that revision is recorded in our drawing as well, right? It gets clouded in the shop drawing, right? And also updated in our title block, right? The shop drawing also comes in with your tables, and these get generated. And what you're seeing in there is just that NC file going out to your warehouse for fabrication. Right, once again, okay, actually this is quite cool. I can show this. Advanced Still itself is a very powerful still modeling and detailing solution. Advanced Still coupled with Dynamo can provide the most powerful 3D detailing solution on the market. And however, there's a great potential to further automate the still modeling. And this can be further enhanced using our visual programming technology, which is Dynamo in this case here. Now, you can imagine to change this in Advanced Still, and this is not in Revit, this is an Advanced Still and Dynamo linked to our Advanced Still model. And we're able once again to do different design options. In this case, we're adding a note for our beam sections, right? And adding a string note to our section name as well, right? And in this case here, you'll see in a moment, if we add in this case, we added in the code for our section and updated our Advanced Still model almost instantly, right? And there's a type of ability Dynamo introduces to Advanced Still, right? The ability to quickly link up components to a code or a script and quickly update your Dynamo model. Right. Now, obviously, once this is done, the fabrication and installation stage, or construction stage, using Advanced Still and also a bit of Navisworks as well, we're able to drive workshop processes using model data from Revit, plan construction sequencing, perform clash detections. I'll show you that in a moment. Verify field as-built track materials with BIM 360. We won't get into BIM 360 today. Also able to share as-built model with contractor and owner, and you're also able to use point data from the model to drive field layout using our robotic instruments, and that's done using your BIM 360 point layout tools, right? And just quickly, using Revit, Advanced Still, and Navisworks Manage, we're able to do stuff like clash detection, interference check, model aggregation, and obviously do your 4D scheduling as well, right? And just very quickly, what I'm showing you here is the ability to export an Advanced Still model into Navisworks, right? All of the objects, properties generated in Advanced Still will import as well into your Navisworks. This gives you the possibility to review your model, right? And such as also calculate distances. For example, in that case there, calculate distances between your beam and your railing, right? You can redline and create mock-ups inside of Navisworks using our redlining tool. And when it comes to planning the project, the timeliner feature can help simulate the direction of your design, right? This is 4D scheduling. And once scheduling tasks and roles are assigned to objects in your design, Navisworks will allow you to perform a 4D simulation, right? We're then also able to run clash detections, right? In this case here, it's a bridge taken from Revit with rebars, right? Just give me a second. I don't want this to play audio. Right. So you can just see the it's fine, guys. I'll just let this play. But okay, what you're seeing there, it's a clash detection done on rebars. Obviously, this can be done on steel connections as well using Navisworks. And this type of detail, it's very difficult to check inside of Revit and Advanced Steel, but using a tool like Navisworks, which picks up the components from either Revit or Advanced Steel, we're able to run clash detections and manage the reporting as well from this, right? If you look in there, you'll see that the clashes between the two rebars on there, right? Okay, right, so that is the golden triangle workflow, right? I'm not sure if you guys are still there, but I'm just going to stop there, right? And I'm just gonna give you guys time to ask questions. I see there are 4 questions that have been asked there, right? There's a question there for add steel handrails. I see the typing is a bit incomplete, right? And okay, I'll move on to the next question from someone. When we export Revit to Advanced Steel, I've been struggling with section sizes not coming out correct. What is causing that, right? Solomon, I can do a support session. We can book it with Salome a bit later. But what could be happening there is basically as you export from Revit, you need to define your standards, right? Now, Advanced Steel has international US standards, and you can create your own ones as well. So you need to make sure that the standards from Revit and Advanced Steel match, right? And you'd be able to, then you wouldn't have an issue with your section sizes. Okay. Next question coming from Johannes. Which package is appropriate for reinforced concrete detailing? Right. I would, Johannes, I would recommend Revit. Right. There's a lot of improvement done for rebar and reinforcing. And the nice thing is you can still send that reinforcing detailed drawings to robot to analyze again once you've created your detailing in Revit. Okay, so just to answer your question once again, Revit is the preferred, I'd say the preferred tool for reinforced for concrete detailing. Okay, thank you, Saeed. There's a question again from Giannis. Do you structure and design engineers use robot for steel and concrete design, inclusive of reinforced concrete detailing? Yeah, once again, yes, they do use, you can use rebar design. The nice thing with robot for rebar design, we can once again do a session for you. You can generate these rebars in robot as well, right? What I'd have to look at is the link for updating your rebar detailing in Revit as well. Okay, guys. It is 11:02. I can still give you guys a few minutes, seconds to ask your questions. But just remember, as Salome mentioned, there is a link that she's shared in our chat, right, where our webinars are hosted on our YouTube channel. You can also access this webinars again on our website, right? Okay, one more question. There's a question that came through from Leslie. Does Revit have advanced tools to create bending schedules. Yes, you can create bending schedules in in Revit, right? And the nice thing with Revit 2021, we didn't have shape code 83 previously. Now you can create that shape code 83 for your stools, right? And then also add it onto your advanced steel, onto your Revit bending schedule. And Leslie, just so you know, Modena has created Revit templates with bending schedules already for you. If you want us to assist you with that, you can also contact us, either myself or Salome, after the presentation, and we can guide you through that as well. Right, Johannes, I see your question. There are some other design suites like Master Series that link to Revit. Why would SA engineers change over to Robot, right? Once again, we get this question quite a lot, right? SA engineers have been forced to use other solutions, mainly because Robot was not out of the box ready for our region, right? Now, the advantage that Robot gives us is the bidirectional function between the analysis model and the Revit model, right? So if you've made changes in Robot, you're able to quickly update your Revit file as well. If you've made changes in Revit, you can update to Robot. I would need to explore Master Series and obviously other design suites that are available in the industry. I hope that answers your question, Dirk. Solomon, the template, I'd have to check with Salome, but we will get back to you on that one to see if it's really available. Right. Okay. Thank you, Ignis, for the compliment. Thank you guys once again for joining the session. Right. Salome has added her email address on the chat. Right, at salome@modena-aec.co.za. And it's just easier for us to go through account manager to do this, just to control communication and make sure that everyone is answered. Okay, right. Okay, right, I'm going to end off the webinar there. And once again, thank you guys for taking your time to join the session and also spend time with us. I hope this was informative. And if you have questions, once again, just take note, we are available. Right. Okay, I've never done this. I'll go back again to the questions. Just 2 more questions that came through just before I end. Dirk says, thank you. Quite hectic to get to know and get to use to new design. Quite hectic to get to know and get used to new design packages. If they have a link to Revit, even if only one directional. I know the learning curve for some of these solutions can get quite high, but the nice thing is once you've learned it, the productivity is improved quite a lot, right? And you would notice as well, right? So you would notice that in the industry, Robot is starting to pick up quite a lot. There's an anonymous question. How would you integrate Plant 3D within this workflow, right? Plant 3D, right, for your PNID stuff, right, using BIM 360, right, and Advanced Steel also links with Plant 3D, right? So what I've seen in the industry, guys would create their piping on Plant 3D and then still do their steel work on Advanced Steel. And the nice thing, between Plant 3D and Advanced Steel, the two softwares are bi-directional. From which version of Revit do we get these advanced tools of concrete detailing? So now we're talking about 2021, right? Leslie, we've been able to do rebar or reinforcement detailing in Revit, I think from like way back since like 2008, almost 2012, 2014, right? As the softwares have been getting updated, Autodesk has just been updating certain features, right? Like for example, your shape code 83. Like, so if you're working on 2020, 2019, 2018, 17, right, you would still be able to do your reinforcement. Thank you guys for your time, right, and enjoy the rest of your day.